Welcome to today's Explainer. You know, everything around us, literally everything we interact with, is matter. But what's truly mind-blowing isn't just that matter exists, but that it effortlessly shapeshifts between three fundamental states every single day, usually right in front of our eyes.
So, think about this. How are an ice cube and a cloud of rising steam identical? Visually and physically, they behave like entirely different substances, right? One is a stubborn, rigid block, the other is a floating, airy vapor. Yet, at their core, they're the exact same chemical substance, water. It's just expressing itself in totally different states. It's honestly a masterclass in physical transformation, showing us how one substance can completely alter its identity without changing its core makeup.
Section 1. Meet the three states.
Okay, let's dive into this and figure out the rules for each state, which really boil down to two things: shape and volume. We'll kick things off with solids. A solid is defined by having a definite shape and a definite volume. Essentially, solids are uncompromising. A solid stubbornly keeps its structural integrity no matter what container you force it into. Like, if you drop a square ice cube into a round glass, well, it remains a square ice cube. Its shape and the absolute space it occupies are rigidly fixed.
Moving on to liquids, the rules start to bend a bit. A liquid maintains a definite volume, but it has no definite shape. Unlike those rigid solids, liquids are highly adaptable. They fluidly take on the geometry of whatever container happens to hold them. Pour a cup of water into a tall vase and it stretches upward. Move that exact same cup of water into a shallow bowl and it flattens right out. The volume stays perfectly constant, but the shape? That's entirely negotiated by its environment.
Finally, we have gases. And this is where the physical rules completely loosen up. A gas has absolutely no definite shape and no definite volume. It is on a mission to expand. If you trap steam in a tiny box, it fills the box. Release it into a huge cavernous room, and it'll effortlessly spread out to fill every single corner of that space. Neither its shape nor its volume is locked in.
Section 2. The particle view.
So far, we've only been looking at the macro world, the stuff we can see. But to truly grasp why a solid is rigid while a gas expands, we have to look at the invisible building blocks making up all matter, particles. Imagine if you could shrink all the way down. The spacing and speed of these microscopic particles is the actual underlying code that dictates every state of matter. Let's look at the blueprint.
Now, what's really interesting when we compare these states side by side is that the microscopic differences are totally stark. In a solid ice cube, particles are packed incredibly tight. They're just vibrating in place without any room to roam, and that's exactly what gives solids their fixed shape. But add some energy to turn it into a liquid, and those particles break their rigid structure, allowing them to fluidly slide past one another. That is why water flows. And once it becomes a gas, like steam, wow, those particles spread out completely, moving rapidly and bouncing everywhere, allowing gases to expand infinitely.
Section 3. Science in your kitchen. You know, you don't need a high-tech lab to observe all these particle behaviors. You really just need to make dinner. Your kitchen is a phenomenal, real-world laboratory. When you put liquid juice into the freezer to make ice pops, you are literally forcing those fast-moving particles to slow down and lock into a solid grid. When you boil a pot of water for pasta, and let's be honest, inevitably turn your back for a second and let it boil over, you're adding heat until those water particles fly into the air as steam, turning liquid to gas. And that morning dew on your lawn? That's just invisible water vapor in the air slowing down overnight to form liquid drops. It's high-level physics happening right alongside your morning coffee.
So matter isn't just some static concept stuck in a textbook. It's a dynamic, ever-shifting part of our reality. Which begs the question, what state changes are happening around you right now entirely unnoticed? The next time you pour a glass of water or watch the dew dry in the sun, remember that you are witnessing billions of invisible particles vibrating, sliding, and flying free. Thanks for joining me for this explainer. Keep your eyes open and keep observing.